recording. So welcome back to Math 140 Business. This is now lecture number 6. And at this point in the class, we have finished the first 3 chapters. The first 3 chapters were on visualizing distributions, pie charts, bar graphs, histograms, that kind of thing. Second chapter was on measures of center and spread, mean, median, mode, standard deviation, median, Q1, Q2, Q3, the IQR, range. Chapter 3 was on the normal distribution and density curves in general. But there was a question somebody asked, a review question. How do we find the standard deviation of a set of data? Well, my first answer is take out your calculator and have your calculator do it for you. But if you really want to know how to do it by hand, let's demonstrate it on a set of data. So give me a few numbers. People shout out some numbers. Give me some numbers. How
47.
7, 23. What else we got?
Or 20.
27.
27.
24.
24 and 8. Okay, that's it. No, too late. You missed out. So 6 data points. This is how you find the standard deviation. Well, you're going to first find the mean, X bar. How do you find the mean of a set of data?
N plus 1 over 2.
N plus 1 over 2.
Add them all together and divide by the amount of data you have.
Yeah, so X bar is 5 plus 7 plus 23 plus 27 plus 24 plus 8 over 6. 30, 35, 45, 55, 62, 72, 82, 86, 94 over 6. 94 over 6 is going to be 15.6 bar. If I did that correctly. Anyone check my math? Okay, well, just trust me. So you have the mean 15.6 bar. And now we want to find the standard deviation, which is the square roots of, you take the first data point, you subtract the mean and square it. The second data point, you subtract the mean and square it. Third data point, you subtract the mean and square it. Fourth data point. Can anyone guess what you do there?
Subtract the mean and
Square.
square it.
Wow, you guys are good. And you do that for all of them. And then at the ends, you take all of that. Normally, I'd like to do this on one line, but I can't fit it. And you divide by what? Anyone remember?
N plus 1 or N minus 1.
And minus 1. So in our case, 6 minus 1. So 3, 4, 5, 6. So 15 minus that squared. Okay, I have that. And then I do 7 minus that and I square it. Add that together. 23 minus that squared, add it together. 27 minus that squared. Add it together. 24 minus that squared, add it together. 8 minus that squared, add it together, divide by 5. Take the square roots, and I get approximately 19.8. The math is not hard, but it is annoying. So why not have your calculator do it for you? Right? Yes, no, maybe so. Anyone?
Yes, sir.
Yes.
Yeah. So that's how you find the standard deviation. Of course, someone mentioned something about N plus 1 over 2. While we're here, let's find the median. And we'll see which is easier, finding X bar and S or finding the median and the IQR. Let's take a minute to do that one too. How do I find the median here?
You put the numbers in order.
Put the numbers in order. So let me go back to the top and put them in order. Let's see, I got 5, 7, 8, 23, 24, and 27. Okay. Hey, Sarah, what's up?
Hi.
What's
Sorry,
up,
I'm late.
girl? That's okay. I'll forgive you.
Thank you.
All right. We didn't really start yet, so I'll mark you as present. And Amaya's here too? What? Crazy. So we're just missing Alan and Jonathan. Almost at a full boat today. Okay, so how do I find the median?
Line them up and pick the middle number.
Pick the middle number, but there's 6 data points. There is no middle number. How do I find the middle number?
You add the 2 center points and then divide by 2.
Okay, 8 plus 23, 31, 15.5. So the median is 15.5. Notice how the median and the mean are not that far away from each other. What is Q1?
Seven.
7. What is Q3?
24.
24. What is the IQR?
14?
Um,
No, it's
your
17.
math is a little suspect there. How much?
17.
17. And what do you see about the IQR and the standard deviation? Those are relatively close as well, because they're both measures of X bar and the median are measures of center, and S and the IQR are measures of spread. So they should be relatively close to each other.
How we counted the IQR?
I'm sorry, the IQR is Q3 minus Q1.
Okay.
Steve, what's up? Question?
No, I was just gonna say, how do you find the IQR? But you already answered it.
Yeah, IQR is Q3 minus Q1. It is the interquartile range. Anywho, before we move on, yes,
What's so important about the interquartile range?
it's a measure of spread, just like the standard deviation is. You know, it gives you a numerical measure of the typical data point and how far away it is from the center. So if the data is really spread out and lots of stuff on the sides, you're gonna have a high standard deviation. But your IQR is not gonna be as high because the IQR is only cares about the middle 50%. So having some outliers in the end is not really gonna affect it, which is why we use the IQR for skewed deviations that would affect the standard deviation and the median, and the mean, I'm sorry, and the mean.
What determines choosing an IQR and choosing standard deviation? Because I know, like you said, outliers and stuff, but is there like a quantitative way to say, okay, at this point, these outliers are too much, we'll go to IQR?
To be honest, I don't know the answer to that. I in this course, you'll never really have an ambiguous situation where a person can realistically pick one or the other. It'll usually be very clear. It should always be very clear which one's appropriate.
Okay.
If there's outliers or it's skewed, you use the median / IQR, both of which are resistant measures. And if it's symmetric with no outliers, then you would use the mean and the standard deviation. Someone asked, how do we find the standard deviation on calculators again? You got to put your data into the stat list and then go to stat calc and do 1var stats. And it'll give you the mean, the median, Q1, Q3. It'll give you the 5-number summary, it'll give you all of them. And it also gives you the standard deviation. So it gives you lots of data.
Wait, Professor, how do you get to calc?
If you hit stat,
Yes.
there's 3 things on top. One of them should be calculate.
Okay.
Right? My calculator charge, I can't find my charger anywhere. I think I lent it out. And I have no idea. Everyone's denying taking it. All my students in my high school. Like, I know I lent it out. One of those little shits took it and is not giving it back. I know it. I know it. But they're all denying it. So my calculator's dead. I have to use my other calculator, which can't really do stats.
Somebody took your calculator?
Huh?
Somebody stole your
Oh,
calculator?
no, not steal. Someone asked to borrow my charger. I lent it and I have no recollection who. And I asked every one of them, and they're like, it was me. So, yeah. What can you do?
Professor, I guess we're matching now.
Huh?
I guess we're matching. You have the same calculator as me.
You have an HP?
Oh no, I thought it was a TI 83.
Oh, baby, HP. Hewlett Packard, that's the way to go for real heavy duty math. Except for
Oh,
stats.
wow.
Yeah, it's a lot better.
Professor,
Yeah,
so SX stands for standard deviation, correct?
well, S stands for standard deviation, and if you're using X to represent your data, we'll quite often see S sub X. As we're gonna see in this chapter coming up, we're gonna have two variables at the same time. One of them X, one of them Y, so you're gonna have S sub X and you're gonna have S sub Y. So the subscript just kind of denotes which variable that you're dealing with.
Okay.
Okay. Any other questions before we move on to the next exciting chapter?
Yes, sir. You said we click stat, right?
Stat, calc, one var stats. You see it? Is it
No, I
far-
can't find it.
If you hit the stat button, what do you see on top?
It says edit calc tests.
Calc, go to calc. Hit enter. What do you see now?
It says edit and then sort A, sort D.
No. Go to calc. Move your cursor to the right to where calc is highlighted and hit enter.
Oh, no, it says list.
No, that's for
then-
the first one. You gotta go to the right. I can't show you. When you hit stat, there's three things on top. Edit,
Oh, I got you. Hold on. I gotta turn on my camera.
okay, turn on your camera. I'm gonna unshare. it so you guys-
For the TI 84, right? the
T84, yeah, go ahead and share, because
Yeah.
my thing's broken, so you go share.
All right, well, you press dang, is it not gonna focus? All right.
There
You
you go.
press stat and then you go up. Oh wait, no. You move to the right and then it should just all be, oh wait, yeah. Oh, and then you click var1, the one var thing. And you press enter and then
And then go down to
use-
calculate.
calculate and then you press enter and then it'll give you all this. And it says like the Q1 median, Q3, and then I don't know. It says everything else.
Yeah, S sub X, the one
Okay.
over there on top, that's your standard deviation. I can't show you, but, yeah, did you get that?
Yeah, I got it. We input the numbers in it to get the
Yeah.
answer.
You gotta put the stuff in the list, otherwise it doesn't know what what to calculate from. So you put it all in list one, and then you go to one var stats, and it gives you everything you need. Okay. Oh.
Do
Okay.
you have a YouTube video up on that by any chance?
I'm
Maybe like
just-
from
I'm
another
just-
class?
On just that alone, no, but you'll certainly have it in whatever lecture we covered it in, because they're all up on YouTube. All
Alright,
my,
sounds good.
they're all on YouTube. I just don't remember which. Anyone remember which lecture specifically it is that we covered that in? Calculators, geez, what the freak does that mean?
I
Calculate,
think it might have been the second one, if I'm correct.
you kids and your weird ass lingo. Jeez, what does it mean? All right, anywho, I want to start chapter 4 now. Unless there's any last questions on 1, 2, or 3.
When will we have our chapter 3 quiz?
When's the homework due? Well, the homework will be due a week from today, right? So we'll have it a week from today. And that'll be a in-class quiz. Oh my God, we're gonna see
Wait,
it
are we having a
for next
a
week.
quiz today?
Yes, we are. Chapter 2. Yeah,
Ah, nice.
these are not surprises. These are all announced. Quizzes are always the same day the homework is due. All right, so let's go.
When we have
Huh?
hello.
Yeah, go ahead.
When we have quizzes in person, is it gonna be on Launchpad also?
Yeah, I don't want to write stuff. That'll take time. So I think it'll be on Launchpad as well. But then do you guys bring in your computers and stuff? Normally when you have classes on campus, because if someone does not, I don't want them to be penalized for not bringing something in that they can do it online. So maybe what I'll do is I'll print out and I'll also have it online so that those who bring their computers can do it online and those who want to print it out can print it out, making me grade by hand. And, you know, thank you in advance for that. But maybe we'll do it that way. But anyways, isn't it so exciting that next class we're going to see each other in person?
Are you excited?
Not really. I'm actually kind of dreading it, but you should be excited. Okay, so chapter 4, scatter plots and correlation. So everything in the first 3 chapters, everything that we did so far is was one variable at a time. We never had more than one variable. If I'm calculating heights, if I'm calculating weights, if I'm calculating IQ scores, if I'm calculating this, if I'm calculating that, it's always one variable at a time. But what if I want to talk about or consider the connection between one variable and another? For example, suppose I'm interested in how many yawns a person has throughout the day as a function of how many hours of sleep they had the day before. Do I think that there should be a connection between them? Hi, professor, just make sure you're the TID4 plus CE. Yes, that is my calculator. So, you know, in statistics, we very rarely just look at one variable. We are more inclined to talk about whether one variable has any effect or any connection to another variable. And as such, we want to have methods of talking about the connection between 2 variables. And this is going to be the subject of chapters 4 and 5. And chapter 4 is on scatter plots and correlation. And we're going to start with the difference between our 2 types of variables, explanatory variables and response variables. So definition, a response variable measures an outcome of a study. An explanatory variable may explain or influence changes in a response variable. So if I were to graph one axis for my response variable and one axis for my explanatory variable, which axis do you think would get associated with which variable? Which one would go with which?
Vertical axis for the explanatory.
And horizontal for the response?
Yeah.
Is that your typical experience when it comes to algebra, that the response, wait, what did you say again? Maybe I misheard it. Hold on, say it again. I want to make sure I heard you correct. I had a moment of weakness. What do you say?
Honestly, I just forgot what I said.
Yeah, I forgot what you said.
So.
The vertical is explanatory and the horizontal, well, the Y is explanatory and the X is response.
Okay, so it's not that, it's the opposite. Because the X-axis is your input and your Y-axis is your response. If you think of basic algebra, Y equals X squared. What's the input in something like y equals x squared? Do you input x or do you input y?
X.
X.
The x, but I got too much hesitation on that one. Or at least it seemed to be too much hesitation on that one. But yes, x is the input. You tell me x, I plug x into my function, out pops y. You give me 2, out pops 4. You give me 3, out pops 9. So the explanatory variable or the independent variable is on the x-axis, and the response variable or the dependent variable, because it depends on the x variable, goes on the y-axis. So for example, if I was to measure the relationship between, as my example that I mentioned earlier, between yawns versus sleep hours, which of those do you think helps explain the other? Does the amount of sleep hours explain how many yawns, or does the amount of yawns explain how many hours?
In this case,
Yawns.
would the sleep hours be the x axis and the yawns be the y?
Yes, the sleep axis would explain or help explain how many yawns. I don't look at someone who yawns a lot and say, I mean, if I see someone who yawns a lot, I'll be like, dude, how many hours of sleep did you get? But if I see someone who had a good night's sleep, I'm like, dude, how many yawns did you get? It just doesn't pop up in conversation. We think of sleep explaining the number of yawns, not the other way around. Another example might be height versus age. Would you say, if you had to assign this explains that relationship between these variables, would you say that the height of a person helps explain what their age is? Or would you say that the age of a person helps explain what their height is?
I think it's
age.
the height.
Yeah, I think age helps explain height, especially in, young people. In fact, isn't that what doctors measure when you're a child and you go to the podiatrist or pediatrician? Which one is it? Is it podiatrist? Maybe a kid is a foot problem, it's both, but
Pediatrician.
pediatrician, right? So when you go to the pediatrician and the doctor measures, how tall you are and says, oh, okay, well, in your age group, you're in the 48th percentile, whatever. They're saying at this age, this should be the height. And this is what your height is. Are you short for your height? Are you tall for your height? Are you just right, etc.? The height is explained by the age. Now, you should be very careful when talking about explanatory variables and response variables, because quite often one thing can help explain something else, but yet not necessarily cause the other. For this one, sleep hours and yawns, is there a connection, or can you go one step further and say that there's a causation? In other words, would you say that the amount of sleep hours causes a person to yawn more when they don't have a lot of sleep versus when they do? Or is it just like a unbelievable coincidence or something like that? Which would you say?
There's causation.
It seems to be that there's causation. I mean, historically, when I don't get a lot of sleep and I yawn a lot, I can usually attribute it to my sleep. For age versus height, I know age is not the only thing that has an effect on height. Obviously, genetics does. Nature versus nurture. I'm sure there's many other things that have a role in height, but age most likely has some direct relationship to it. Here's an example of one of my favorite examples of a relationship between two variables. Age of death versus number of cars owned. age of death versus number of cars owned. There is a clear statistical connection that shows that people who have more cars tend to live longer. Clearly, the statistics does not lie on this. As a general rule, people with more cars tend to live longer than people who have either no cars or few cars. Now, does that mean that if I want to live long, I should go out and buy a few extra cars? Would you say that the number of cars owned causes a old age of death versus a young age of death? Or would you say that there might be a connection between them, but not a causation? Can anyone give me-
Connection.
So what's the connection? Why do people with more cars tend to live longer?
Like,
maybe
they have
more
more
income.
money.
They have more money, usually. They have better medical care and better insurance and better this and an easier, just an easier life overall. They live heather lives. They live heather lives. I'm not sure what a heather life is, but I want one of those. Oh, healthier. That's an awkward autocorrect. So yes, there is a correlation, but not a causation. So be aware, warning, warning, warning. Correlation does not imply causation. Just because something has a high correlation to something else in a numerical way that we will quantify very clearly, or technically have our calculator do it for us, does not automatically imply causation.
What's the definition? What's the definition of correlation then?
Well, we're gonna get to it. We're gonna get to
Okay.
correlation. It's the title of chapter, well, it's somewhere in this chapter, correlation. I think, yeah, it's in this chapter. We will get to it. But for now, correlation is more of a intuitive notion of a connection between two variables. Steve, triple cheese, what's up?
You already know. I just have a question. What is the definition of causation one more time? Because I don't want to get it through my head.
Yeah, again, causation does not have a mathematical definition. It's an intuitive definition. When one thing helps cause another, we say that there is causation, that this causes that. So number of sleep hours certainly helps cause how many yawns you have. Your age certainly helps cause your height. Of course, other things do too. I'm not saying it's the only one. But number of cars owned does not cause you to live longer. But there is a connection going on behind the scenes. There's a variable lurking behind the scenes, often called a lurking variable. And that variable helps explain the connection between them. So at this point, these are qualitative definitions and not quantitative definitions. Okay?
Thank you. That helped a lot.
All right, so now, when you have your data, so for example, let's say I go to, my pediatrician, got that right that time, and I ask for information on age of children versus their height from when they are very young. So age, we'll talk about age in months and height in inches. So if I were to plot, let's say I get information on, let's say 100 children. And for each one, I plot, oh, at this age, they had this height and so on. No units here. This is just a qualitative understanding. We're not getting into the math yet. What do you think would occur as the ages get bigger? What would happen
They
to the
get
height?
taller.
The height would increase
they
as
get
well with it.
taller.
The height should increase as well, correct?
Could we assume that it's in a linear fashion or that doesn't matter?
Well, that's the big question of this chapter, is that, is the connection linear or is it not linear? That is the central theme of this chapter. But even if it was linear, do we really expect ages and heights across all these hundreds and hundreds of children to follow a perfect line?
Nah.
No, even if it was linear, the data might look something more like this. Right? Some are tall for their age. You might have a couple outliers here and there. Really, tall and people for their age or short people for their age and so on. So even if you expect a relatively linear relationship between them, you wouldn't expect all the data points to fall perfectly on a line. And this is very important in statistics. When we talk about a linear relationship, we don't mean linear in the sense of a basic algebra course where they literally fall on a line. That's what linear means. In algebra, y equals mx plus b, we have a straight line. When we talk about linear in a statistics course, we mean, is there an overall linear pattern or is there not an overall linear pattern? So would you expect if I measure age from, let's say, 0 months up until something like, 12 months, would you expect an overall linear pattern?
Yes.
Okay, I don't really know how babies work. Do they grow faster, slower? I mean, do they grow really fast?
growth spurts.
They grow through even the first year?
Yeah, it's crazy.
Them babies grow, bro.
Hey, I don't know that shit, man. That's not my.
I got 2 kids. Yeah, I got 2 kids, and
great. That's great.
they grow
Yeah.
small to big in like the blink of an eye.
Okay, well then stop.
But it varies.
It varies. Okay, so let's assume for the sake of this discussion that there is a general linear pattern for the first year. Now, I don't have any experience with this myself. What I can remember from back then, I don't remember any of it, but we'll go with what Frank's saying that they're not, but let's assume that there is. Do I, or can I assume, even if there is, that same linear pattern would continue indefinitely?
Yes.
So you're saying then that when someone is like 80 years old, they're now 9,000 feet tall.
Oh, no.
No, so whatever, you got to be very careful when you have your scatter plot. Whatever relationship that you see in the scatter plot, do not try to extend that relationship beyond the scatter plot where you have no data. That's called extrapolation, and extrapolation is bad. And every year I put on a test one example of using your scatter plots to predict some data points. And the answer is always, sorry, you can't do that because that's extrapolation. You cannot take your data and say, I want to apply this to a point over here as well, way off the charts. So if I had a point way down to the right, you can't use my data. So don't extrapolate. Don't extrapolate. You can only, anyone know what the opposite of extrapolate is? It's a cool word, but you probably never heard it.
Interpolation?
Oh shit, someone did hear it. Okay, you can only interpolate. Don't extrapolate. You can only interpolate. That rhymes. That was kind of fun. Ooh. So when we talk about scatter plots, so what do we care about? What do we look for? What do we look for in a scatter plot? What are the things that we're looking for? Number one, the overall pattern. Is it linear? Is it quadratic? Is it exponential? Is it logarithmic? Is it circular? Is it this? Is it that? What is the overall pattern of the data? Now, in this class, we will never have to worry about what to do when it's not linear. That is reserved for a more advanced class. If you guys realize that statistics is now the end all and be all of your life based upon your experience here in this class, and you switch to a major in statistics, it happens almost never. Then you worry about that later. But for us, if I give you a scatter plot and I say, hey, what's the overall pattern here? then your answer would be, oh, that kind of looks like a parabola. That's a quadratic pattern. So you have to be able to recognize patterns based upon data. What is the overall pattern? 2, are there deviations from the pattern? You might have a wonderful looking pattern, but you might have a couple points here and there that are deviations. We care about those. Are those mistakes? Are those legitimate, but we want to ignore them? Are they legitimate, but we can't ignore them? So what are the deviations? And we try to understand why the deviations are there. In terms of the overall pattern, we want to talk about the direction. We want to talk about the form. And we want to talk about the strength. So these 3 things, this is what your overall pattern is: direction, form, and strength. Form in our class will be linear versus anything else. Because as we're going to see, the only math that we're allowed to do is when we have a linear relationship. If it's not linear, you can't do the math. Now, there are ways of making non-linear relationships linear, but again, beyond the level of this class, so we're not going to worry about that. When it comes to direction, we really only have 2 possibilities: positive versus negative. What do you think I mean when I say positive versus negative?
Is going up or down?
Is it going up or down? And yes, while it's possible that I can go up in one spot and go down in some other spot, again, in this class, we really don't try to complicate things. We're just looking at the basics, trying to make you understand the concepts, and we don't really throw anything at you that's really, really complicated in that sense. So in our case, yeah.
Does it also mean like the slope, like a positive or negative slope?
If it has a positive slope, we say it's a positive direction. If it is a negative slope, we say it's a negative direction, right? So that goes.
Oh, so it's the same. Okay.
Basically the same thing. And then we have the strength, which is strong, moderate, or weak. And strong, moderate, and weak is kind of hard sometimes to eyeball, because depending on the scatter plot that you see, it's not always so obvious whether it's strong, moderate, or weak. As we're going to see in this chapter, we're going to have a mathematical way of computing the correlation. And from the numbers that we get, we're going to conclude, yes, it's strong or moderate or weak. So you might guess based upon the scatter plot and say, oh yeah, I think it's strong. So for example, if I showed you this, that looks fairly strong. But maybe I zoomed out so much and the data is really, if I would get, closer, the data is really, all over the place. And it's just a matter of how close you are or how far away you are. Very hard to eyeball these things. So the math will do that for us. We don't have to eyeball them. You just calculate. And how do you think we're going to calculate? Anyone take a guess?
Numbers?
Well, yes, because that's, yeah, you can't really calculate without numbers, but I'm looking for something a little more amusing. Calculator, that's correct. We're going to have our calculator do all the work for us, because if you thought standard deviation was bad, you ain't seen nothing yet. So the correlation formula is really, really annoying. I don't want to do it. You don't want to do it, but our calculator, he loves to do it, or she, I don't know. All right, so any questions so far? All right, what I wanted to see if I can share my screen yet, or I still have these. No, still can't do it. Shit, crap. Okay. So, but you know what? Does anyone here? You guys can all access the Launchpad, the book on Launchpad, correct?
Yes.
All right. Well, then I might at some point call upon someone to share their screen, because I can't share mine to demonstrate, in fact, you know what? Would anyone mind volunteering for that right now? Sharing their screen? I'll
I'm
tell
down.
you,
Try it out.
tell you what page to go to in the book. Because I don't want to graph all these scatter plots, but if you go to chapter 4, we'll start page 100, we'll start looking at some scatter plots. Would anyone mind doing me that favor, please? Is anyone on it, or are we all waiting for someone else to do it?
What page?
You
Up,
said
start
chapter
page-
4, right?
Page 100,
Chapter
yeah.
4, page.
In my book, it's page 100. I'm not sure if it's page 100 on the online book, but we can start there. We can right.
You said scatter
Graph
plot
that we're
or
looking
just-
for.
Oh, I see a percent of graduates taking the, okay, so go to the next page. Let's go to the next page. Okay, so there's one scatter. Okay, now that's a good scatter plot. Go back. Okay, where'd you go? There, oh, there. Oh. There it is. Okay, so here we have a scatter plot. This is a scatter plot of the mean SAT mathematics scores in each state against the percent of that state's high school graduates who take the SAT. So if you look on the x-axis, it's the percent of graduates taking the SAT. That's our first variable. And if we look on the y-axis, we have the average, the state mean. And this is our first example of a scatter plot. So what we have here, would you say that this is linear?
No.
It certainly does not.
Negative.
Well, it certainly has a negative, it's negatively associated.
Mhm.
It looks like it.
It does
or
not
it's
look like
linear.
it's, yeah, it does not look like it's linear to me.
Yeah.
In
it's
fact, if
negative.
anything, what part of it is making it not linear? If you had to get rid of a part of it to make it linear, which part would you get rid of?
The right section.
Well, if you got rid of the right
I'm
section,
playing the left.
I think the left is a
This left.
okay, so what I want you to do now is I would like you please to go to the next page. It might actually be 2 pages down. Let's go and see. Go to the next page, please. Okay, this is the same data. Not all of the same data. They removed some data points. But what they did here is they actually included a designation to separate the Midwest region from the Northeast region. When you look at them like this and you see the region separated, other than that outlier Indiana and maybe even Ohio to a little extent, this shows a deep distinction between what we had on the left side of the graph and what we had on the right side of the graph, correct?
Yes.
So if you didn't denote this or didn't care about it or didn't recognize it, then you see a very strange pattern where you have a lot over here and a lot over here, and it's not really linear. But when you look at it by a region, you see a sharp distinction that, okay, the Midwest states tend to have very high SAT scores for very few people taking the SAT. And the Northeastern states tend to have very low scores or relatively low scores for lots of people taking the SAT. And you might start to ask yourself, why should there be this geographical distinction? Do the Midwest states just teach it better? I mean, if they did and the scores were higher, why are so few people taking it? So does anyone have a reason why we might have a scatter plot like this, which is really subdivided so distinctly between these regions? Can anyone guess?
Maybe in the Northeast you have to take it.
Well, if in the Northeast you have to take it, okay, that's actually a pretty good one. Right? If you don't have to take it in the Midwest, then who are the people that would be taking it?
Smart people.
Smart people who might want to get into schools that require it. Whereas if you don't have to take it, why take it? So as a statistician, we don't always have numerical reasons for things. Sometimes they got to think about what's going on behind the scenes and come up with explanations, which may or may not be true, to explain the data, to explain the scenario, and to kind of make a distinction between what we see and, what we want. In this class, not so much. 99% of the questions in this class are going to be very, here's what you have, calculate something, define something, explain something. Very little of come up with a reason why you think this might be the case. But in statistics out there in the world, as a statistician, I would venture to say that that's even more important sometimes, to take your data and when you're analyzing it, to come up with a reason why the data is what it is. Does that make sense so far?
I'll be for real. I just didn't even understand what you just said.
I'm sorry, say it again, please.
I don't understand what you just said.
What I just said or what I've been saying the entire time
Like the thing you just said right now.
about what a statistician has to do.
Yeah.
Sometimes a statistician has to come up with a reason why data is the way it is. And those reasons are not always going to be in the numbers.
Got it.
Sometimes it goes beyond the numbers. Okay, now, if you look, okay, so go ahead and stop sharing for a minute so I can go back and share mine. Thank you very much. I might call on you again. Someday the stamina will come. I'm gonna call upon you to do me a favor. No, nobody? No, okay, you know what? You guys,
Father.
oh yeah, I would hope so. All
Yeah,
right,
who hasn't watched that movie? Come on, David.
you never watched it?
No, I watched it. I said who hasn't watched it?
I don't know. I did it and no one commented. I was like, I don't know what's going on here.
Wait, what movie?
Oh my God. What movie? What movie?
Wait.
What movie?
Or show? I don't know.
It's
What?
The Godfather, baby, The Godfather.
Oh yeah, I have not seen that.
Now you're gonna say you never watched like The First Bride or something like that. That's just like blasphemy. Blasphemy, I tell you. Anyway, so when you have a scatter plot, notice you can only plot data if the variables are quantitative. You cannot have a scatter plot for categorical variables. There are no numbers. You can't get a connection. But as we saw in that last scatter plot, there are ways of adding categorical variables to it by using different colors, different shapes, etc. So to add categorical, God damn it, categorical, is that spelled right? I think so.
Yes.
All right, to add categorical data, use different colors or shapes.
Professor?
Yeah,
So another example could be like, let's say, scores of students taking their finals based off a morning final and an afternoon final, and you would just have the colors changed.
yeah. If you think that taking it in the afternoon or morning should have some kind of effect on scores, if that's the only thing you're looking for, though, you can't use a scatter plot because that's categorical. So you have to have some quantitative variable that might affect the scores. Give me a quantitative variable that you think might affect the scores.
Hours of sleep.
Okay, hours of sleep the night before. Then separated by morning classes and afternoon classes. That, go for it. Maybe you'll see something there that no one's seen before. Maybe you'll have a connection. Maybe you'll be able to explain something. But you got to start with quantitative data.
Quantitative and then lead on to categorical.
Yeah, exactly.
Okay.
What? There you go. Okay. Okay. So, any questions so far? All right, so now we move on to measuring linear association. And I'm going to underline linear 4 times. I'm going to put it in a bubble and I'm going to have lightning bolts coming out of it or going into it because this is so important. And I can't draw, so, stop making fun. But this is all about measuring linear association. Correlation, our formula that we are going to use does not measure association that is not linear. You can have data like this. If that's my data, when I measure my correlation, it's going to give me a value of 0. Because looking at this data, there's no line through the data that best fits the data better than any other line. There is no linear correlation here. But obviously there's some connection because this is the perfect circle. You wouldn't have any shape like this if there wasn't some kind of connection between them.
So there's a correlation, there's an association, just not a linear one.
Just not a linear. And in this class, if it's not linear, we just don't care. Now, I'm going to give you the formula for the correlation, but we're not going to actually use it to calculate because again, I'll have my calculator do it for me. But given data points, x1, y1, all the way through x and yn. So you have n data points. And each data point has an x value and a y value. So you have x1, y1, you have x2, y2, all the way through x and yn. R, which is our symbol for the correlation, is equal to 1 over n minus 1 times x1 minus x bar over sx, y1 minus y bar over sy, plus, and we do that all the way through xn minus x bar over sx, yn minus y bar over sy, and then we divide by n minus 1 as we did in the front, and that is our formula for the correlation. What is x bar here?
The mean
Of what?
of your distribution.
Gotta be more
The
specific.
data.
Which part of my data?
The points?
Which part of the points? Because
The
there's,
X points?
yes, it's the mean of the x values. We just take the first element of every pair and calculate that mean, that is x bar. What is y bar?
Mean of the y values.
The mean of the y values.
Professor,
Yeah,
why didn't you use parentheses for the equation?
where? The whole thing?
Yeah, you used the I forgot what they're called.
Brackets?
Yeah.
I like to put brackets around my parentheses, not parentheses around my parentheses. It's easier for me to distinguish them.
Okay.
If I got parentheses all over the place, I forget which one goes to which. If I have brackets, it's easier for me to see.
But they're the same, they do the same function.
They do the same thing. They are grouping symbols. There's no preference of one over the other. If I was a computer programmer, I would have to use the same one all the time. But when by hand, by eye, it's easier for me to distinguish them when they have different shapes. What is S sub X?
Your sample data?
More specific?
Standard deviation for the X values.
Yes, standard deviation of the X values. What is S sub Y?
Standard deviation for the Y values.
Standard deviation of the Y values. And finally, what is N?
Total number of data you have.
Yeah. Number of data points.
For the N, we're counting both X and Y together, right?
Uh-huh. Every pair is a single data point. Now, before we actually sit down to calculate some R's, some facts about R. If you switch X and Y, so you take your X values and your Y values and you switch them, so your data flips. What would happen to R, the correlation, the connection between them?
It would switch to, right? It would be the opposite.
No, R would not change. R measures the connection between two variables, does not care which variable you're calling the explanatory variable and which one you're calling the response variable. It doesn't care one way or the other.
That only applies to R, correct?
That's just R. This is just R. Next, R does not depend on units. So if you measure something in inches and you switch to centimeters, or you measure it in grams and you switch to kilograms, R does not change. It does not care what units you use. It will give you the same value. R greater than 0 implies positive. R less than 0 implies negative. R equal to 0 implies no correlation. And finally, R is always stuck between -1 and 1. The closer R is to 1 or -1, what do you think it means if R is close to 1 or -1?
The more whole it is, so
Say
that'll make
again?
it stronger, right? If
Yeah.
it's more whole,
Yeah.
that'll make it
stronger-
stronger.
Yes, stronger the correlation. So I'm gonna give you a couple seconds to write that down. And then I'm gonna ask the person, I forget who it was, who shared their screen, to share again in a minute. Because there's some scatter plots I want to go through in the book. And hopefully one day I'll get my calculator fixed, my computer fixed. And I can do it myself. Does anyone need more time copying these things over?
Yes.
All right.
I have a question. Can you say, can we use our notes in the quiz? Can we use our notes in the quiz during the quizzes?
Hey, I don't care. Do whatever you want.
Yeah.
Yeah. And doesn't
I mean,
matter-
if we will be in the class.
Oh, in the class? Yeah, what the hell? Why not?
Okay. Thanks.
No problem.
So it's okay, we can just use the formulas then? Given to us, like,
Yeah, any formula that you have, you can use. You know, I mean, if you have a, yeah, I mean, for what though? I mean,
just like a reference.
yeah, I mean, use your notes anytime you want. No need to memorize this stuff. I mean, on tests, in my experience, people who don't know what they're doing and have all these things written down, or they bring the book and they're flipping through the book looking for things, they tend not to finish because they're spending all their time looking things up and they don't know what they're doing. Notes should be for, you know, if you forget, or for a quick reference, or for a very, you know, hard to remember formula. You should be relying on notes left and right. It's so by the end of the semester, it's gonna be a lot of material. And you really need to understand not just the formulas, but how the formulas work, or else you're gonna have a very tough time, as people tend to do. All right, can I unshare? Everyone got this? All right, good talk. All right, so go ahead.
Yeah.
And whoever shared before, please share again if you don't mind. And move forward to the next page. And then to the next page. All right, and to the next page. One more. Okay, you went too far. I'm not sure how that happened. Yeah, that's the one I want. So scroll down. Yeah, okay, there we go. No, too much. Why are you still going? Go back. Are you there? Yeah, there you go. Okay. There, yeah, that's the one I want. Perfect. So what we have here are 6 scatter plots. The one on the bottom right, would you say that's strong correlation, moderate correlation, or weak correlation?
Strong.
I mean, that seems to be extremely strong. And look at the correlation coefficient. First of all, it's negative because it's negative correlation, but how close to 1 is that?
0.01 away.
Yeah, I mean, that's very, very close to 1. We expect very, very strong correlation. If you look at the one to the left of that, that has a correlation coefficient of 0.9. And already it's at the point where I would start to question how strong it is. Even 0.9, yeah, it seems pretty strong. But you get any looser than that, and now already you're kind of moderate. So if
So what
I
are the
had,
break-even points?
so there's no distinct numbers where you can say from here to here it's this, from here to here it's this, and so on. But as a general rule, I would say you need to be past 0.9 to be considered strong. So 0.9 to 1 or negative 0.9 to negative 1, that will be considered strong. Look at the one in the middle right. We're back to being negative. Would you say that's strong, moderate, or weak?
Weak.
Well, I wouldn't call it weak.
Or moderate?
You can still clearly see that it is negative, right? When you first look at that, you don't hesitate to say which way is the line. I mean, it seems down and to the right. And if you can do that without too much hesitation, it's probably at least moderate. And that's a correlation coefficient of negative 0.7. If you go to the one to the left of that, that's a correlation coefficient of 0.5. And already at this point, I'm starting to think that's kind of weak. Because it takes me a second to really see a line there. If I have to give that a linear, you know, up, bottom left to upper right line, it might take me a minute or two to see that. And if you look on the very top, If you had to give a line to the one on the left, what direction would that line be?
Looks like top left to bottom right.
Well, they say the correlation is 0. So they're saying there is no line there whatsoever. But this is the point of, it's hard to eyeball these things because you might see a left to right line and someone else might not. So always do the math and don't worry so much about doing it by eye. The one to the right of that negative 0.3, I mean, if you say so. I don't really see a line there too much, maybe a little one down, only because they told me it's negative, but that's certainly weak. So if I had to give cutoffs, I would say something along the lines of 0.9 and above is strong, 0.7 to 0.9 is moderate, 0.5 to 0.7 is weak, and anything less than 0.5 is just so weak or non-existent as to for you to conclude that the data is most likely not linear. So if you're not getting at least 0.5 or higher for the correlation coefficient, or on the negative side, you don't want to conclude linearity. Your conclusion is this is not linear. Does that make sense?
Yes.
So go ahead, please, and unshare for a second. I'll just write that stuff down. Thank you very much for your help. I appreciate it. You get 10 extra credit points that don't do anything to your grade. So congratulations. So if the absolute value of R is greater than or equal to 0.9, we'll say that's strong. And if it's between 0.9 and 0.7, we'll say that's moderate. And if it's between 0.5, what the hell, I just do that, 0.9 over here, and 0.7, we'll call that weak. And if the absolute value of R is less than 0.5, it's either very weak to non-existent. Now, since we talked about the concept of a resistant measure for the mean, for the median, standard deviation, IQR, what do you think about the correlation? Resistant or non-resistant?
Resistant, non-resistant.
Non-resistant, because remember, R uses the mean and standard deviation, both of which are non-resistant. So since X bar, Y bar, SX, SY are all non-resistant measures, R is also a non-resistant. And so ends chapter 4. When I look at my tentative schedule that I happen to have here for this class, they have me finishing chapter 3 today and finishing chapter 4 next time. So we are one class ahead of schedule. And what that usually means before a test is I give a review day before a test. If we're ahead of schedule, I give a review day. If we're not ahead of schedule, I don't have time for a review day. So looks like at this pace, we'll have a review day. As for when the exam is, usually my first exam covers chapters 1 through 5. And that's it. So usually my first exam covers 1 through 5. Which means, yes, Philip.
And what does that say after R? It says R in, and I don't know what it says
R-
after, under it.
R is also a resistant, non-resistant measure. Hope you're not,
Okay, thank you.
hope you're not, taking a shot at my penmanship. I did after all win best penmanship in second grade, still the finest achievement of my life.
I believe you, I believe.
I wouldn't. All right, I mean, it's true, but not from what I'm writing here. Anyway, so let's talk about test number 1. Today is Thursday of week 3. And chapter 5, also relatively small, will probably finish on Tuesday. Even though we'll spend a few minutes saying, what's up, seeing each other in person, that'd be so cool. And then if I give a review day on, let's say, Thursday. So what do you guys think about having our first test? I'll give you a choice of 2 days. I feel that this is a democracy and we should take a vote, and then I'll just do what I want anyway. But I'll give you a choice of the Thursday of week 5 or the Tuesday of week 6. So quickly in chats, when I say go, I want you to write either either Thursday, that's Thursday of week 5, which is, okay, I said when I said, what the frick, what, stop, don't go yet. Okay, so your reading comprehension certainly needs a little, I feel like you're all lemmings at this point. Like if we were like, in the army and one person took that first shot and like, hold your fire, and everyone goes, like, it's all, oh my God, geez, you're all still going. So what the hell's El Martes anyways? Let's see. Good thing we aren't majoring in English, seriously. So I can't even count this because everyone went, even before I said, who let, Miguel, it's your fault. You went first.
You should take a poll.
I blame you for everything. I should do what?
Mr. Professor, you should just do a poll on Zoom.
I should do a poll on Zoom, but I'm too lazy to set that up. So since none of that counts, since everyone went before I said to go, because you didn't finish, let me finish what I was saying so I can count this stuff.
Professor?
Hold on. I have to recoup. So when I say go, and people are going again. Okay, so thank you, Andrea. Thank you. So nobody write anything in chat yet. Just leave it. Just leave.
I might have a better way.
What's your other way? Because I have a great way, but no one's listening. Huh?
Maybe you could tell people to put their thumbs up, like put your thumbs up for week 5, and then you could count all the people that put their thumbs up for week 5, and then you could do and then you say people to put their thumbs up for week 6, and then you just see whoever has the most thumbs up within those weeks. You can open the voting.
Hold on. That's a good one. Hold on. That was a good one.
Let David talk, everybody.
That was a good one. That's actually pretty good. The problem with that is that there's so many people here that when I split screen, some people are on both, and therefore it's going to skew my counting. So as good as an idea of that, if you let me finish, I think I have a good idea here. I just need you to just listen. So again, the options are, because right now we are in Thursday of week 3. So the options are Thursday of week 5, that's a week from 2 weeks from today, or the Tuesday following in week 6. So all I want right now, Amaya is the cutoff, the ha right there. Anything after this counts. If you split, no, you're don't stop. What is that? Here's a poll. What the hell is that?
Let's set up a poll.
Amazing.
It's like we can.
Okay, so that was you kids these days. Okay, go on that poll. That one works. Go on that poll, everyone.
Are we just, so is this for the midterm?
This is for the first exam. This is for the first exam. Either vote for Tuesday, week 6, or Thursday, week 5. This is amazing. I've never heard of this site, straw poll. But that was like in 2 seconds. That was like better than anything I ever thought of in my life. So good call, whoever you are. But everyone, please click the link and pick either Tuesday, week 6, or Thursday, week 5. How do I see the results? Can I just click results to see the results? Oh my God, it's 13 versus 13.
I had a question. Is the
Yeah.
exam gonna be on Launchpad as well?
No, I don't think so. I think the exam will be written.
Okay.
I think the exam will be written, but I haven't decided yet. Let's take a look. 13. Oh, now it's 20 to 13. Wow, that changed. 20 to 14. There's like 40 people here. So unless you're abstaining, I'm gonna give you 30 more seconds. Actually, I don't think it matters at this point.
I don't see the poll anywhere. Where's the poll?
He gave you the link in the chat.
Oh, there we go.
I'm just curious to ask, why do some people want to do it on week 5?
Maybe get it over with.
Yeah, get over it while you still remember everything.
'Cause
Maybe.
most people are gonna ask for the next week over, and then they don't study the whole weekend. So
Well, yeah, usually that's what happens. You know, if you have
Early the better.
trying to pay like- usually what happens, like when I put it on Tuesday and I go, oh, I have an extra weekend to study, amazing. Usually what happens is you start studying Monday night, so it doesn't really matter in my experience, but you know, I give you the option anyway. But right now it's 22 to 15. The week 6 is won it. So the test will be Tuesday of week 6. I know, I hear what you're saying, but you know, democracy and all that shit. So, also to be honest, the argument that get it over with so I don't forget it, that's not the best argument, since it'll all be on the final and you'll need it all for the second test and for the third test. So try not to forget it, because this course builds, every chapter builds on the one before it. So forgetting it, bad. But nevertheless, the people have spoken. And the final results are in 22 to 15, Tuesday of week 6. Is there going to be a study guide for the exam? That's a great question. I'm not really the biggest fan of study guides, but if you really want one, I put up on the on Canvas amongst the links in files, I think, is the workbook. Scared and excited. Sorry, what was that?
I said, yes, please.
One more
We
time?
really need it. I said, yes, please. We really need it.
Okay, well then it's
It's
up there
okay.
already. It's up there. The
Okay, thank you.
workbook is up there. And of course, the homework questions are your greatest, well, Launchpad sucks, but the concepts really are what's most important. But if you can do the workbook questions, you should have no problem. And again, I'm not here to trick you. I'm not here to really struggle. The questions are straightforward. When I give the exam every year, people don't do well, granted. And then when we go over it in class, the overriding emotion or sentiments is how easy it really was if I only would have studied harder. So it's not designed to be difficult. It's just designed to see if you know the basics. And if you do, you should do fine. If you don't study it because, this stuff's easy, I got this, then chances are you won't do fine. That's just historically what happens. So Alex, thank you for that poll. That was lovely. And I'm going to stop recording now because we're fairly done.